And here is the drawing. It is drawn in Simul IDE version 0.4.15-SR10. And guys, Simul IDE is not just for drawing, but it is a simulator for Arduino and other electronic components. So what we have here is a power supply that will supply the stepper motor's driver. And the drivers N1, 2, 3, and 4 here will be connected to Arduino's pin 8, 9, 10, and 11. While your power supply will receive power independently, it just needs 7 to 12 volts, or you can use a 9-volt battery for this one, or converter that is not above 12 volts. This stepper motor should be connected to this socket of the driver, and you won't get lost in connecting the stepper motor because it comes with a female socket that will rightly fit here. The home button or the limit switch is connected to pin 4, and the other pin of a normally open button will be connected to the ground. So you do not need to connect it with resistor because it will be using an internal resistor of the Arduino, and your Arduino here will go to the computer. Alright guys, I think that's all about for this circuit, and let's go to our sketch now. Here is the sketch of this video about locating its angle and counting the steps. And again, we need to declare our library, which is the stepper.h, and a total steps of 2048 in one revolution of this type of stepper. And here is the object, my stepper. Then the stepper speed is initially declared to 5, and the maximum speed you could get from this type of stepper is 10. And this is the direction. The home button works like the limit switch. This is homing for tracking the home button. This step count is a variable for counting the steps, and the switch flow is used to track complete flow the switch statement is making. Here is the rev as an integer, or this is to count the revolution, and this one is also used to count the revolution in float, and the angle is an integer. This is the variable for our switch statement, the stepper step, which is initially equals to 0. And the pin outs of the stepper driver are connected to 8, 9, 10, and 11 of the Arduino, as you have seen in the circuit. In the setup, the pin modes N1, N2, N3, N4 are outputs, and the home button is an input pull-up. And these are the codes used to stop the stepper if the limit switch is activated. So we have my stepper dot set speed, stepper speed, so the stepper will rotate in 5 RPM, and homing equals digital read home button. So it reads the home button. So while homing equals to 1, or if the limit switch is not activated or the valve is not in a closed position, this stepper will rotate in this direction. And to get out in the while loop, homing must be put inside the while statement so that you could get out in this loop if homing becomes 0. And when homing becomes 0, then the N1, N2, N3, N4 must be put to low. And then that is our 0 position, that is the assumed position of the valve that is closed. Then we will put a delay of 5 seconds before it will proceed to the void loop. Here in the void loop, the switch statement stepper step will be executed, and in case 0, N1 must be put to high, and in case 2, the N2 will be put to high, and the other are lows. So as you go on until the N4 will become high like this. And one complete flow of our switch cases, we call it the switch flow, and it created 4 pulses, right? And that means that the stepper in a single switch flow is rotating in 4 steps. And therefore, we need 512 single switch flows to create one revolution. And to do that, we must have a condition like this. If switch flow is greater than -1, which we initialize to 0, and if the steeper step is less than 3, what do you mean by this? Steeper step is initially declared to 0, and if it is less than to 3, then steeper step equals steeper step plus 1. So it will move from case 0 to case 1, case 1 to case 2, case 2 to case 3, and that is 3. 0 to 1, 1 to 2, and 2 to 3, and that is 3 steps. And what makes a 4 steps is from 3 to 0. So you must go back to 0 to make a complete flow. And else, because our switch case is just up to 3, else if it is now become more than 3, you should go back to 0. And 0 is always less than 3, so it will rotate. So after case 3, it will go back to case 0, and after case 0, it will go to 1, case 2, case 3, and back to 0. Then we have our switch flow plus plus. So the first count will begin after one complete flow, then our switch flow will adds up. Alright, and you can now make an increment that your step count is equals to switch flow times 4, which has a maximum of 2048 in one revolution. So in one revolution, or to get your revolution, you have to divide this step count with 2048, and that is the float. So it will display, or it will count with a decimal, while the rev here is an integer, so it will just count the whole value. So step count divided by 2048. And this is the secret here, how to get your angle. So revolution minus rev times 360. And note that revolution minus rev would never be greater than 1. Otherwise, will be greater than 360, which is not correct. So guys, these formulas here is what this video all about. And to print in the serial monitor, just do it like this. Alright, so let us upload. Thank you and have a nice day to everybody.